Hello students, welcome back to my channel once again. So today we will be covering the CBSE board grade 10, the first chapter, real numbers. This is going to be the part 2 video. So in the previous video, part 1, I explained what do you mean by real numbers and also explained about the Euclid's division algorithm. So we will continue with this and we will also take a look how to solve different type of problems using Euclid's division algorithm. So the question is, use Euclid's division algorithm to find the HCF of 184, 230 and 276. In the earlier video, I explained about to solve Euclid's division algorithm using the Euclid division algorithm to find the HCF of two numbers. Now we are going to take a look how to solve it using three numbers to find the HCF. So first, what we need to consider in this case, first we will consider two numbers and we will apply the Euclid division algorithm to find the HCF of two numbers. So we will take first two numbers 184 and 230. Since in this case 184 is smaller than 230, so 184 is going to be the divisor over here and 230 is the dividend. So let us apply that. Now divide it. So 46 is the remainder. So now we know that Euclid's division algorithm says that dividend equal to divisor into quotient plus remainder. So here dividend is 230, divisor is 184, quotient is 1 and the remainder is 46. So we'll keep on doing this process until we get the remainder as 0. So now this 46 remainder will become the divisor and earlier divisor, that is 184, will become the new dividend. So now let us divide it. 46 into 4 is 184 and there is no remainder. So now we will write in terms of the Euclid's division algorithm 184 equal to 46 into 4 plus 0. Since now we got the 0 over here, okay. So now what we found out that 46 is the HCF of two numbers 184 and 230. Okay. Now we are going to take this 46 number as a divisor and the remaining number, that 270, is that is going to be the dividend. Okay. So now 46 6 are 276 and there will be no remainder. So 276 equal to 46 into 6 plus 0. Okay. So you can clearly see that 46 is the divisor over here. Okay. And that is going to be the HCF, because whenever we have the 0 as the remainder, in that case whatever will be the divisor, that is going to be the HCF of the number. So HCF of these three numbers 184, 230 and 276 will be 46. Now the another problem. Here also we need to find out the HCF using Euclid's division algorithm. The numbers are 136, 170 and 255. So first we are going to take two numbers 136 and 170. So 136 will be the divisor over here and 170 is the dividend. So the remainder is 34. So dividend equal to divisor into quotient plus remainder, that is the Euclid's division algorithm. So now here it will be 170 equal to 136 into 1 plus 34. Now 34 will become the divisor and 136 will become the dividend. So 34 4s are 136. So there will be no remainder. Now we have to write it in terms of Euclid's division algorithm. 136 equal to 34 into 4 plus 0. So out of these two numbers we got the HCF, that is 34. Now we need to take 34 and the third number, that is 255. Now we need to find out the HCF of these two numbers. So 34 7 is 238. So we got 17. Now 255 is equal to 34 into 7 plus 17. Since it is non-zero, so again we have to apply the same Euclid's division algorithm. So now 17 will become the divisor and 34 will become the dividend. So 72 is the 34. So now we got the remainder as 0. So we'll write in terms of Euclid's division algorithm 34 equal to 17 into 2 plus 0. So whatever will be the final divisor when we got the remainder as 0, that will be the HCF of all the three numbers. Okay. So in this case, HCF of 136, 176 and 255 will be 17. Now let us see another type of problem. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So let us see how you are going to solve this type of problem. So here they are asking for positive odd integers. Okay. So positive odd integers which will be in the form of 6q plus 1, 6q plus 3 and 6q plus 5. So positive odd integer, we can denote it as a. So let a be any positive odd integer, okay, which will be in this type of form. So you can clearly see that if we take a integer, positive odd integer a, and if we represent it in terms of Euclid's division algorithm, that is a equal to bq plus r, right? That is the Euclid's division algorithm. So here b is the divisor. So in this case, we can consider that b as 6 over here. Okay. So b is equal to 6. So now apply Euclid's division algorithm. We will get a equal to bq plus r. So a is equal to, here b is 6 means 6q plus r. So we know that r value can be vary from 0 to less than b. Okay. So 0 included, but it should be less than b. So in this case, since b is equal to 6, so 0 less than equal to r less than 6. So possible values of r will be 0, 1, 2, 3, 4, 5 because it is less than 6 and 0 included. So now the possible remainders are 0, 1, 2, 3, 4 and 5. So a is equal to 6q plus, so 0, so that means that is 6q, or it can be 6q plus 1 if we just apply the r value over here, or 6q plus 2, or 6q plus 3, or 6q plus 4, or 6q plus 5. Okay. Now here q is some integer. So that is already mentioned in the question. Now a equal to 6q. So 6 is, 6 is an even number, right? Because it is divisible by 2. So it is an even number. So whenever we are multiplying 6 with q, so that is always going to be the even. So even if we multiply a number with an even number, always it will be even. So a equal to 6q is even. But 6q plus 1. So whenever you know odd is a 1 is a odd number. So whenever we are adding even numbers, because 6q is even, you are adding a even number with an odd number, that is going to be always the odd number. So 6q plus 1 will be always the odd over here. Then comes to the 6q plus 2. So 6q is even and 2 is even. So whenever we are adding two even numbers, that is always going to be even. So 6q plus 2 is even. Now 6q plus 3. In this case, 6q is even, but 3 is odd. So even plus odd always gives you odd. So this will be odd. 6q plus 4. 6q is even, but 4 is also even. So even plus even always gives you even number. 6q plus 5. So 6q is even, but 5 is odd. So even plus odd gives you always odd numbers. So since a is odd and q is some integer, so they are telling that q should be an odd integer. So we have to neglect the even numbers. So 6q, 6q plus 2 and 6q plus 4 we have to neglect. So as they are even. So a will be the rest of other numbers, that is 6q plus 1, 6q plus 3 and 6q plus 5. So any positive odd integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. Okay. So if they give you any type of question, like if they ask you for 4q plus 1, 4q plus 3, so that you have to apply the same way. Just instead of 6, you have to use the divisor as 4. Okay. Now moving to the next question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, so what is they are asking, that what is the maximum number of columns in which they can march? Okay, so how many maximum numbers of columns they can make? So now there is a army band of 32 members are there, and 616 members of contingent of 616 members are there. So 32 band members and 616 contingent members. So now if we arrange them in two columns, let's see the structure for arrangement in two columns. So for 32 band members, in arranging in two columns, each column will have 16 members. And for 616 contingent members, if we arrange it in two columns, it will be 308 for each column. Now we get the answer by dividing the numbers by 2 in this case. That means here 2 is the common factor for 32 and 616. Now for 4 columns, if we arrange it in 4 columns, let's see the division of the band members. So each column will have 8 band members, and for 616 contingent member, each column should have 154 contingent members. So here also we get the answer by dividing the numbers by 4. So that means 4 is the common factor of 32 and 616. But in the question we want to arrange it in the maximum column, right? So that means we have to find the maximum, that is the highest common factor for 32 and 616. So the number of columns must be selected in such a way that it must be maximum and must divide both the numbers. So that is both the numbers here is 616 and 32. So since 616 is greater than 32, so let's apply the Euclid's division algorithm. So 616 will be the dividend over here and 32 will be the divisor. So 32, 296, so 19, what will be the remainder? 8 will be the remainder. So now apply the Euclid's division algorithm, divided equal to divisor into quotient plus remainder. So it should be quotient, okay? So we get 616 equal to 32 into 19 plus 8. Since remainder is not a 0, so now we have to consider this remainder as divisor and 32 as the dividend. So 8 4s are 32, okay? So then there will be no remainder. So now apply the Euclid's division algorithm. We will get 32 equal to 8 into 4 plus 0. So we know that how to find the HCF. Whenever the remainder is 0, we have to consider the divisor, that as the HCF. So in this case, HCF of 616 and 32 will be 8. So the maximum number of columns in which they can march is 8. Now let's take a look at the next question. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. Okay, so this is the same type of problem that we have done earlier. So let a be any positive integer and b is equal to 2 here. because it is in the form of 2q. So we have to consider the divisor b as 2. So then by Euclid's algorithm, a is equal to 2q plus r. So here a is for some integer and r value will be vary from 0 to 1, because we know that always r should be 0. It can be equal to 0, but always less than the divisor, that is 2 over here. So here r can be 0 or 1. So equal to 2q plus r for some integer q greater than equal to 0, and r can be r equal to 0 or r can be 1, because 0 less than equal to r less than 2. So a equal to 2q plus 0, that is 2q, or 2q plus 1. If a is in the form of 2q, then a is an even integer, right? So we know that because 2 is a even, so whenever we are multiplying any number with a even number, that will always give you a even number. So also a positive integer can either be even or odd. So therefore any positive odd integer is of the form 2q plus 1, because 2q in this case, a can be 2, there are two forms. One is 2q and another one is 2q plus 1. So now 2q is always the even and 2q plus 1. So 1 is the odd number here, right? So even plus odd gives you always an odd number. So 2q plus 1 will be always the odd. So we can already we have seen that whenever it is in the 2q form, then it is always in the positive even integer, and whenever it is 2q plus 1, then always it is in the form of odd integer or positive integer. Okay, so that is the proof. Hope you understood this one. Okay, so that's all for today. Hope you have understood this. If you haven't, please rewatch it once again, and still if you have any doubt, then you can put it in the comment section. And if you like my video, then please hit the like button and share with your friends. And don't forget to subscribe, otherwise you will not get notified for the upcoming videos. So for that, you just need to press the bell icon. That's all for today. Thank you. Bye bye.